Hello friends, in this part of the quicksort algorithm, we are going to discuss the function, the C function of the quicksort algorithm which we have written on the board and explain it line by line to you. And if we have missed the previous video of the entire concept of the quicksort algorithm which we have discussed before, you can go to the above link and refer to the previous video in order to get into the details of the explanation of the quicksort algorithm, how it works on a data list. So please go to that video and refer to that in order to get to understand this entire code of quicksort algorithm. So let me just explain the algorithm. This algorithm consists of two functions. That is, one function is the quicksort function and another function is the partition function. So we have written two functions on this in this algorithm. That is the quicksort function, which is a recursive function which will call itself in different steps of this function in the line of codes which we will get to see a bit later. And after that, after the execution of this function, after writing this function, I have written another function which helps us to partition, the entire list which is given to us in order to get the quicksort algorithm partitioned into two subsets which follows the divide and conquer approach. So let's get started with explaining this part, that is void quicksort int a. What is this? Nothing to return from this function. So this is the return type is void. Name of the function has been written as quicksort. You can write any other name of your choice. This is the array which we need to get sorted, which the base address of this array has been passed by this argument. By this argument, we pass the base address of the array, and this is another variable int low, and this is another variable int up. So we declare two other integer variables in the list of the arguments of the quicksort function definition. After that, we get inside the function body and write and declare another integer variable I. Now we see what we have written. If up greater than low. What is up greater than low? Up is nothing but, let me just write a simple list in order to make you understand what we are doing. 1, 2, 3, 4. Suppose let us take 0, 1, 2, 3, 4 elements. So suppose this is 44, this is 33, that is 11, and this is suppose 22. Now what to do? This 0th position is nothing but the low position, and this number 3 position is the up position. So this is low is 0, up is 3. Now we will see if up greater than low. So up is 3, low is 0. Definitely up is greater than low. Then we come to the if block and write this code. I is equal to partition a low up. What we have written? I is equal to partition a low up means we are calling the partition function which is written below in order to get the entire list of these 4 numbers divided into two sublists separated by the pivot element which we have discussed in the previous video. What is the pivot element? You will get to know what is the pivot element if you refer to the previous video. And this pivot element will help us to separate the entire list of these 4 numbers into two sublists on either side of it, and we will apply the quicksort algorithm on the left sublist of the pivot element and on the right sublist of the pivot element by means of these two line of code. This quicksort a lower I minus 1 executes the quicksort algorithm on the left sublist of the pivot element, and this portion helps us to apply the quicksort algorithm, that is this function, in a recursive way on the right sublist of the pivot element. So this is for the left part, left sublist. I am writing a comment beside it so as to make you understand a bit clearly, and this one is for the right sublist. Now in this pattern the algorithm goes on in a recursive fashion until we get a sorted array, that is the array which will be ultimately sorted in an ascending order. Now we come to this partition function. Partition function is written like this. It will definitely return an integer value which is nothing but the index position of the pivot element, which helps us to find the this function will help us to find the position of the pivot element. That is, the pivot element will find its position in the entire list. It will discover its position and stay over there, and it will just separate the list into two separate sublists. So this, what is this integer? This value is nothing but the index position of the pivot element found by this partition function. So this int is the return type, that is the integer value to be returned. Partition is the name of the function which we have given. You can give your any name of your choice. This has also 3 arguments, just as we have taken in the above quicksort function. That is int a, that is the base address of the array which is going to be partitioned. Int low, int up. What is low? I have referred to low above and referred to up above as well. That is the lower bound of the entire list and as low, and upper bound of the list as up. That is, in this case, low is 0 and up is 3. So suppose this has a base address of 65586. So this is 65586, and this is, what is this? This is 0 and this is 3. Now we come to the body of the function and see that there are several lines of codes written in this body of function, out of which we have given a declaration section of 4 variables I, P, Q and T, which are declared as integer variables in the first line of the partition function. After that, we initialize P to a value of low. That is, in this case, P will be initialized to 0 because low has a value of 0 when we first entered this function. And then Q is equal to up plus 1. What is the value of Q? Q is initialized to a value of 3 plus 1, that is 4 in this case. So now what we have in hand, 65536 is the base address, low is 0, up is 3, P is 0, Q is 4 because 3 plus 1 gives you 4. So Q is 4. Now see, we will write the variable one by one over here. Suppose low is 0, up is 3, P is 0 and Q is 4. So we have all these values set to the respective variables. Now we come to this line, I is equal to A low. We have written 3 lines over there, and because of paucity of space, I have written it on the remaining part of the function on the right side by separating by this line. So please consider this line to be the 4th line of this partition function. I is equal to A low. What is I? I is equal to A low. What is low? Low means 0, A 0. A0 means what? A0 means 44. See this? A0 means 44. So I is equal to 44 at the beginning. And now see, we have written a while loop having the condition Q greater than equal to P. While Q greater than or equal to P, we will enter this while loop and do some necessary execution of some steps, and see, let us check this condition. While Q is greater than P, greater than equal to P, Q is 4 and P is 0. As you can see from here, I have written the values which were initialized in P and Q. So this condition holds, that is Q is equal to 4, P is equal to 0, Q is equal to 4, P is equal to 0, so Q is greater than P. So we come to this, we enter this loop and see that in the first line there is yet another while loop in this first line, that is while A plus plus P less than I. What is this? Having a semicolon over here means we have to see whether we can just iterate through this line of code if we can. Suppose this plus plus P means we have to pre-increment this P. We have to pre-increment this P and see that if this I is greater than the A plus plus P value. So let me pre-increment the P. pre-increment of P gives you P is equal to 1. So now compare A1, C less than I, is this less than I is nothing but 44 and A1 is 33. So 33 is definitely less than 44. So condition holds and we again pre-increment this P to 2 and see this A2 is 11 and A2 is 11 means A2 is less than 44. So we again increment P and P becomes 3. A3 is 22 which is again less than 44. Then again we increment 3 to 4 and see that there are no position in this. In this case it goes out of the bound of this array. So we come out of this while loop and see this that our maximum value which the P has reached, which P variable has reached is 4. Now we come to this second while construct. While A minus minus Q, very similar to the above approach but in a reverse way, that is in this case we have compared it by pre-incrementing P. In this case we will just we make this comparison by pre-decrementing. We just pre-decrement this Q and compare it with I. So here we see A minus minus Q. So Q is 4 at the initial position. Now minus minus means first you decrement 4 to 3 and compare with I. A minus minus Q means A3, whether it is greater than I. What is I? I is 44. A3, what is A3? A3 is 22. A3 is 22 and which is not greater than I, it is less than I. So we see that the condition is not satisfied. We come out of this while construct. While we see after coming out of this second while construct, we see that the final value of Q which has been obtained is 3 and the final value of P obtained is 4. Now we come to this block, that is this if block. If Q greater than P, if Q greater than P, that is Q is 3 and P is 4. Q is 3, P is 4. Q is not definitely greater than P, Q is less than P. So we skip this entire if section and come out of this while loop and start to see whether Q is greater than or equal to P. Q is 3, P is 4. So definitely we come out of this while loop because Q is greater than P and not equal to Q is less than P, rather Q is less than P and not equal to P, and we come out of this entire outer while loop. So after that, after coming out of this while loop, we come to this line and see that here it is written T is equal to A low. So what is the value of low? Value of low is 0. So T is equal to A0 and A0 means 44. Now we see A low. A low means A0 and we assign the value of AQ to it. What is AQ? AQ means A3. What is A3? 22. We write 22 over here and write AQ is equal to T. AQ means A3. A3 means A3 becomes now what? T. T is 44. Now we see this 22 and 44 gets swapped with each other. So now the array becomes like this. Array becomes like this 0, 1, 2, 3. In this way, now A0 becomes 22, A3 becomes 44 and 1 and 2 will be the same as before. So now the list becomes like this and see what we discover is that what is the value of Q over here? We see that entire 44 has been placed in the 4th position among these 4 elements and all the elements on the left hand side are less than 44. That is the sublist on the left hand side is less than 44 and there is no sublist on the right hand side of 44. So we can easily conclude that we have discovered the position of 44 as the pivot element which separates the list into 2 sublists, one on the right, one on the and another on the left. The left sublist contains 3 elements and the right sublist is empty containing 0 elements. Right sublist is empty containing no elements. So this is the pivot element, and what is the value of Q now? Q has a value of 3, and we will return the position of the pivot element as the return value from the function which we have already referred to while we were discussing about this integer return type. So we will return this position, that is the 3, position 3, that is the Q is equal to 3. We will return Q as the last line. Return Q means return 3 from this function into this value of I, where this partition function was called for the first time. So I gets the value of 3 now. So we return this value 3 now. So see what we have done. Now we will see that the list has been separated into two parts. See this quick sort. Now we will apply the quick sort algorithm to the left sublist first. A lower I minus 1. What is I? I is what is I? I is 3. And what is 3? This one. So A lower I minus 1 means, this is not lower, this is low. So A low I minus 1 is base address of the array. What is low? Low is the same as before, that is 0. And what is I minus 1? I minus 1 is 3 minus 1, that is 2. So we see easily that we will perform the quicksort algorithm on this entire sublist containing 3 elements, 22, 33 and 11. And after that we will come to this quicksort function calling, that is A I plus 1 up. I plus 1 means 4 up to up, and up means 3, where 4 is less than up. So 4 is greater than up, rather, because up is 3, 4 is greater than 3. So up is less than 4. So I plus 1, the lower bound is less than the upper bound. So there is no question of executing this quicksort function, and we can easily match it with the concept that we have with the finding which we have got in the case of the separation of the entire list by means of the pivot element 44 into two sublists, where we have seen that the right sublist did not contain any element, but the left sublist contained 3 elements. So there is no question of performing the quicksort algorithm for the right sublist as it is empty. Now in this way, now we come to describe this quicksort algorithm once again, which we encounter with the help of the base address low and I minus 1. That is, we will apply the quicksort algorithm to this list 22, 33 and 11. So these are 3 elements which need to be considered. So this is 0, this is 1, this is 2. So we again go to the quicksort algorithm in a recursive fashion. This is the base address, this is 0 and this is 2, and perform the algorithm in a similar approach as we have performed in the first iteration and in the first instance of the quicksort function definition which we have described before. And in this way the recursive function goes on calling itself and partitions the array into different sublists, in two sublists on each step, and by the process of divide and conquer, ultimately we come to a sorted list which will definitely contain this 11 as the first member, 22 as the second member, and 33 as the third member. So in that case 44 has found its position, the array will get sorted. So let me just move a bit further in order to get you towards the ultimate goal which we strive to achieve. So now these 3 numbers, out of which this is 0, this is 1, this is 2. Now we see this, we come over here and see up greater than low. What is up? Up is 2, low is 0. Definitely it is greater than low. I is equal to partition A low up, that is we again call the partition function for the second time. A is the base address, low is equal to 0, up is equal to 2, and go to this partition once again. So A is equal to 65586, the base address, this is 0, this is now 2 and this is 0. Now we come to this line, P is equal to low, that is P is equal, low is now 0, up is equal to 2, P is equal to 0, P is equal to 0, Q is equal to 2 plus 1, that is 3. In this way, we will perform the algorithm in a similar fashion as we have discussed before, and get to see that we will discover the pivot element in this way, so that we will have something of this sort, that is 44, then this 11 and 22 will go to this left side, and 33 will discover its position, so that 33 will become the pivot element, and entire left sublist will contain 22 and 11, and then they will be sorted in the similar fashion. So in this way we can see that the quicksort algorithm works by the help of this code. I have explained the entire quicksort algorithm to you, and if you have any doubts and queries pertaining to this entire explanation, as this is a bit of as it is a bit complicated explanation, you can well post your doubts and queries into the comment section below, so that I can address them and come back to you. Thanks for watching this video.